So in regression analysis, what we actually do is, if you want to make sure that what factors influencing your dependent variable, for an example, in our previous example, we want to make sure that whether resources and capabilities influence to the performance of the organization. Sometimes you might have factors influencing satisfaction of customers. So, sometimes you try to find out what determine the usage of internet banking in Sri Lankan customers. Likewise, then, so we need to find out what factors influencing, what cause to change something else, right? So you have several independent variables with one dependent variable. Sometimes you have two dependent variables as well, right? It doesn't matter because we can run several models. So regression analysis, we basically test what factors significantly affect or influence to your dependent variable. So regression analysis, we can run based on the item-wise scale measurements, or we can use nominal scale items and also ordinal scale items. We can use regression analysis. There are several tests available in separate measurements scales. Okay. So then let's look at the example and we will discuss it a little bit more detail. Now, this is a data set I'm using to explain you how to do the regression analysis. So in here, it's basically test the satisfaction of particular websites, right? So it measuring the determinants of the satisfaction of particular website or satisfaction of customer based on particular website. And the dependent variable is satisfaction, and there are 9 independent variables, right? Like the timelines, expertise, thoroughness, objectivity, readability, reliability, design, comprehensive, and practical usability. So all the measurement items are based on the 1.5 scale, and no answering scale is also there, but it doesn't matter for us. Right, it is basically 1 to 5 measurement scale used to measure those measurement items. Right now, this is a data set you can see from this sample I'm using. It has 637 responses. Okay, now we like to make sure that whether the satisfaction of particular website going to be influenced with these 9 factors. So what would be the factors that going to be influenced to the satisfaction of particular website, right? So it's very simple, right? Now we already assuming that this data set is checked with the validity and reliability, right? And then I'm using how to do the multiple regression analysis. So multiple regression analysis means when you have like this kind of several independent variables with one dependent variable, we have to run multiple linear regression analysis. If you have only one independent variable and one dependent variable, you can do with simple linear regression, right? But the same analysis, okay, go to analyze and then go to the regression, right? Then click linear. Okay, click linear. Now you can see the window is open. Now you have to select your dependent and independent variables, right? Now, as you know, the dependent variable is the satisfaction. So you can tick that satisfaction into you can put the satisfaction into the dependent box. And independence, we know that timeliness to practical uses are your independent variable. So you can put it into the independent variable. Here you can see that there are several components coming under the method. So either you can test the entire model, that means entire variables as a one model. That means you put all 9 variables and run the analysis at once, right? So that give you one-time model. That means all 9 variables into one model and make sure that what factors going to be influenced and significantly or not. If you are selecting the stepwise, so stepwise mean they first check what factors significantly influence. one by one. That means first it check the timeliness and satisfaction, then it check the expertise and satisfaction, thoroughness and satisfaction, likewise, right? First we check the enter, and then I will show you how to do the stepwise thing, right? Then please make sure that method is enter. Then go to the statistics, okay? Then you have to check these things, collinearity diagnostics and Durbin-Watson. Why we are checking these two? Because these are some things, these are the measurements. We can make sure that your measurement items are not, your models are not having the issue of multi-collinearity. So multi-collinearity mean, now we know we have several independent variables, right? Sometimes we know that these independent variables are correlate with each other, right? If you run the correlation matrix, you can see it very truly, right? So it correlates, it normally happen. But if it is correlated each item with highly, right, that indicate we are having some issue of multi-collinearity. That is the high correlation among independent variables. If we having that things, so it does not good for our model. That's why we want to make sure that our model is free with multi-collinearity issue. That's why we are checking this collinearity diagnosis and Durbin-Watson. So click them. Then please just take OK. Right? I will do with some other things in here. Just take OK. Right? Now let's see the screen. Right. Now you can see the R-square value. So R-square value indicate, I think you are familiar with those things. R-square value indicate how far your independent variables explain the variation of your dependent variable. That means in this case, R-square value, it says 0.39. So that means at least 40% of the variation of customer satisfaction on particular website will be explained by these identified 9 factors. That is good, right? But it is not very much good, but at least it is greater than 0.3 mean it is good. Okay, so Durbin-Watson factor. So in here, Durbin-Watson factor, normally we believe that if Durbin-Watson factor is between, that means below 0.2.5, right? Sorry, it's below 2.5, right? So it indicates that your model is free of multi-collinearity issue. Right? In your case, you have 1.937. It is less than 0. It's less than 2 even, right? 2 to 2.5, it is better, right? So then your Durbin-Watson is less than 2.5. So that indicate your model is free of multi-collinearity issue. But if it is greater than 2.5, then we have some issue with your model, right? Then we can see the overall significance of your model. So if the sig value, that means we call p value, right? If the p value is less than 0.05, so that means your model is statistically significant, right? Model is statistically significant. Then we can check what factors statistically significant to affect the satisfaction of the customers, right? Now we have 9 factors. Right? How can we check whether those are statistically significant? So you have to check these sig values. Right? You have to check this sig value. Right? If sig value are less than 0.05, if sig values are less than 0.05, we can identify those factors as statistically significant influencing factors. Now you can see timeliness is okay. And expertise is okay, thoroughness is okay, objectivity is okay, readability is okay, reliability is okay, design is okay, but practical usability is okay, and this comprehensiveness having some issue because its value greater than 0.05. That means comprehensiveness is not statistically significant influencing factor on customer satisfaction on particular magazine or website, right? Now, this is the data set you will get when you are taking the method called enter, right? Now, if you are going with the method called stepwise, right? If you are going the method called stepwise, now let's see what will happen. Okay, now let's see what will happen to the data, your result, right? Now you can see the R values. It says model 1 by 1. Now model 1 indicate, here the model 1 indicate only practical usability. Model 2 indicate practical usability plus timeliness. Model 2 indicate practical usability, timeliness plus thoroughness. Now you can see they run the regression while adding one variable at once, right? One variable at once. Then the last one is your 6 variable, so it include all the things, right? And R square change, sorry, I didn't take it in here. Give me 1 minute, I will take it, right? So under the statistics, you have to tick this R square change, right? Now let's see the results. I'm really sorry. Now let's see the result. Here, same, okay? Now these are the models, right? One by one, you are adding variables and run the model. Now you can see R square change. First model R square is 0.2, right? And then it increased by 0.08 once you are entering next variable, right? Likewise, it's increasing value getting high until this, it's getting increased until this 0.4, right? It increasing, but that increasing is not that much valid, that much significant, because it's getting reduced one by one, right? But model 6, until the model 6, all the variables are getting significant. Okay, now you can see in here, this is the model, right? Now the practical usability is the first model, it's significant, right? Then second model include practical usability with timeliness, significant, right? Then practical usability, timeliness, thoroughness, that is a third model, significant. Likewise, model 6 include practical usability, timeliness, thoroughness, design, reliability, objective, it's significant. Now you can see in our previous one, in our enter model 1, the comprehensiveness is not a statistically significant one, right? So likewise here, you can see the last model. You can see the last model, the comprehensiveness is not entering into what, at least none of the models. Why? Because it identified that comprehensiveness is not a significant factor. That's why it's not coming to the model, right? So stepwise model is very important because it's only considers significant factors, not any other things, right? That's why I told you beginning, without going with the enter model, you can go with the stepwise model. It's very important. Okay, stepwise model is very important, so you can do it, right? And other important thing is this VIF values, right? Tolerance and VIF values. I told you that the Durbin-Watson is value we are using to make sure that your model is free of multi-coordinate issue, and we can also check that multi-coordinate issue with the value of VIF, right? Normally, this VIF value has to be less than, this VIF value has to be less than 5. If it is less than 2, it is better, right? If it is less than 5, it also acceptable. If it is less than 2, it's perfect. Now you can see under this model, under this VIF value, all the factors are less than 2. That indicate your model is free of, your model is free of multi-collinearity issue. Okay, right. Then that is the way you are going to check with the regression, right? And we have to check one last thing, because we normally know that your dependent variable, right? We are not checking the normal distribution at the beginning, but now we need to make sure that whether your dependent variable having some normal probability plots, that means it distributed with normally, right? So how to check that one, right? I'm going with the linear regression, right? And then please select now in this command called plots, right? Command called plots, right? Under the plots, here we are taking the residuals. So what do you mean by residuals? Residuals mean how far our estimated values are deviated from actual values. That is the residuals, right? Now, for an example, if you want to estimate something, when we are estimating it, we normally check whether how far estimated values are um, uh, deviate from your actual values, right? So this is the thing we are checking with your dependent variable, right? Now we want to make sure that your dependent variable, your given factors, how far it is going to be extend with or deviate with your measurement factors, right? Then in order to do that, please select this residuals or standard deviations, residual standard deviation into y-axis, and the standard deviation of the or residuals of the prediction into x-axis, right? Then click histogram and then click normal plots, okay? And then click continue, right? Now here y-axis we are taking the standard deviation of the residuals, and here we are taking the residuals of the dependent variable, right? And click continue, click OK, right? And then check. I'm not going to check anything in here because we have already checked those things, right? Now this is your dependent variable plots. Now you know the meaning of the histogram, right? So histogram means this indicate that your dependent variable have some normal distribution data. Your data is normally distributed. It gives very perfect bell curve. It's very good, right? Now this is the residuals. This is the standard residuals of your dependent variable. Now you can see this highlighted plots. That means these highlighted dots are your measurements, right? Now these measurements are exactly go along with your estimated value. So what does it mean? That it means that your estimated or your measurement items are move along with your calculated or estimated values. So it's good, right? It is perfectly good. If it is go something like here, right? Like now this drawing line is going like this or something like that. So that indicate your items, that means your measurement items and your actual values, there are some deviations. There's some deviation. So then it is not good. It's not good, right? But in our case, it is okay. Now you can see this satisfied dependent variable scatter plot, right? Now, if this is going to be some kind of deviation like this, so you have to check again with your data set and make sure that there are some outliers, right? So if you have some data plots like this, right? If you have data plot like this, so that indicate you are having some outliers, right? Then you have to go back to your data set and clean those outliers, right? And then run the regression analysis again, right? So this is the way we normally check the regression analysis, right? Now, and so you can check your regression analysis with your model, right? If you have several things, right? I will do some one additional thing because sometimes students have some control variables, right? Sometimes students have control variables. So then how we are checking? So controlling means we are not taking those into our model, but we believe that those can be influencing to our identified factors, right? Now, let's go back to our data set, right? And in here also you can see, instead of these factors, we are having some gender, age of the customer, education of the customer, profession of the customer, that means its employability, and working hours. So those are some kind of demographic factors, right? But we don't know, but we can make sure that based on our literature, those factors having some influence to the satisfaction of customer. But those are not included in our model. But we can take those factors, this gender, education, like these factors as controlling variable. Okay, then we can put these factors into controlling variable into our regression model and run the model again. Okay, so then if sometimes in your panel, they might be asked that when you are measuring your dependent and independent variables and run the model, they might be asked, you might have other factors, right? How can you make sure that those factors are not influenced into your model? Then your answer is, if you are running with this controlling variable and check your model, then you can say, yes, I put them as a controlling variable, but it does not influence to my model, right? Let's see how to do it. Go to your linear regression again, right? Go to your linear regression again. Now I remove these factors. Okay. Now first I take this, my demographic factors, right? I have several factors like gender, age, education, that means profession, and the working hours. Okay. Now you can see even there are some measure item scale as well as nominal and ordinal scale items, right? So I put it into the independent box, right? Now first I enter my controlling variables, and then you have to put next, right? First enter your controlling variable and then click this next button. So that indicate your first entering are the controlling variables. Okay, that's indicate your first entering are the controlling variables. Then you can enter your independent variables, right? You can enter your independent variables and you can do the stepwise regression, right, as you like. Okay, then other things are okay because we check all the things, R-square change, collinearity, diabeam Watson, right, and plots. I'm remove this thing because I don't need to those thing in again, right, and then click OK, right, and let's see what we can see the result here. Now we have several models, right? Now we have several models, right? Let's see whether we are having any. Yes, only working hours become the significant factor. Since we are having several independent, several controlling variables, only working hours have some significant influence, right? So it's a good point, right? Likewise, you can see here, when we are entering the controlling variable, only working hours getting significant influence, right? Only working hours, no gender, no age, no education level, no profession, only working hours, right? So last model indicate that we are having 1, 2, 3, 4, 5, 6, 7 factors going to be influenced to your customer satisfaction, but working hours is not in your model. So then you can say that we can control working hours, even that other 6 factors getting statistically significant. Okay. So that's the way you have to make sure that your model is perfect. Okay, your model is perfect. Right? Then you can say that you can counter argue that yes, I check the controlling variables, but those are not significantly influenced or except the working hours factor. Right? So likewise, so it's R-square value is also not so much good, but at least it's adequate. Right? If you are getting more than 0.5, that means 50%, 60%, your model is good. Right? Now this is the way you have to check. Right? First check the R-square value. Then check the overall significance of the model. That means your ANOVA test, right? It should be less than 0.05. And then go to the coefficient table and find out which factors significantly influence to your dependent variable. Now, this is the way you are going to check with your regression analysis. So after looking at the regression analysis result, now let's see how we can do this mean comparison test. So before I move into the comparison test, let's see. So mean comparison means sometimes your data set have, like what we discussed previously, gender, income level, and different education level, right, and some other demographic factors. So you might be want to check whether those factors go into, or whether there is some difference between or among those demographic factors and your dependent and independent variables. Right now, for an example, lastly, the satisfaction, and if you take the gender, right, in here you want to make sure that whether the customer satisfaction on particular website going to be changed according to the gender. That means whether males are highly satisfied than female regarding the website satisfaction, or high income people are highly satisfied with the particular website or particular website's features. Likewise, we can make that kind of comparison. We call them as a mean comparison test. Right. So let's see how we can do this kind of 2-3 mean comparison test based on some sample data set. Now, this is another sample data set I'm taking, and this is some kind of, there are several independent variables with dependent variable called environmental citizenship behavior, right? And we have several demographic factors like gender, degree, faculty, and previous job experience, and degree program likewise. Okay. Now, this is your data set, right? Now, in this case, we are having some issue with the some particular demographic factors measuring as a string factors, right? Now, you can see these are letters are there, not numbers, right? So then we are having some issue with the mean comparison analysis. I will let you know how to do it. First, check, right? First, I want to check that whether degree program, right? The degree program, here I'm using this new degree program variable. So one indicates first year students, second year student, third year student, and final year student likewise, right? So I want to make sure that the environmental citizenship behavior going to be differ according to the degree programs. That means whether first year students are highly concerned about environmental citizenship behavior, or final year students are highly concerned about environmental citizenship behavior. Likewise, we can do this kind of comparison. Now, how many groups do I have? So I have 4 groups. That means first year, second year, third year, and fourth year. So I have 4 groups. If you have more than 2 groups, and if you want to make sure that whether which groups are going to be highly concerned about environmental citizenship behavior, so we can run this test, right? Right. Let's go with the analyze. And here you can see the command called compare mean, right? So under the compare mean, if you have more than 2 groups in your particular category, like new degree, I have 4 groups, right? You have to go with one-way ANOVA test, right? If you have more than 2 groups, you have to go with one-way ANOVA test, right? So one-way ANOVA test, first select your dependent list. That means which factor you want to make sure that the changes are happening. In my case, the environmental citizenship behavior, I'm selected. And what is the factor? That means what is the category you want to check the reference. So my one, it's a new degree, right? New degree. Now I want to make sure that whether first year, second year, third year, and final year student have different environmental citizenship behavior. That is my question, right? And please make sure that you have to do this analysis if you are testing based on your objective or your research question, right? Otherwise, you don't need to do it, right? Then press OK. So then you can see the result. Now this is the ANOVA test result. Very simple result you are getting. Then what is your conclusion, right? Now how can you make that conclusion? So conclusion, you can make it here. Look at this sig value, right? If this sig value less than 0.05, right? If this sig value is less than 0.05, it indicates there is some difference between groups with regard to your dependent variable or your target variable. That means there are some differences with environmental citizenship behavior with respect to the degree programs. But the thing is, now the condition is this sig value less than 0.05. If so, there is a statistical significant differences among group with regard to your measurement variable or your desired variable, right? Now we have a question. Which one having the highest environmental citizenship behavior? Which one has the lowest? How can we make sure within this result? Yes, you cannot make any comparison with this. Therefore, you have to go again this analysis, right? That your one-way ANOVA. Then in here, you can see the command called post hoc, right? This is called post hoc. Then click it. And under the postdoc, we are having several mean comparison tests, right? We are going with the very simple one we call Turkey. Right? Go with the Turkey, right? Then continue, then press OK. Okay, now you can see the result. Okay, now what you can see? Now it's make the comparison. It make the comparison with one by one. Now it's first make the comparison with degree program 1 to other degree programs, right? When compare with the degree program 1 and degree program 2, you get the mean difference score minus 0.195. What does it mean? If you are taking the mean value of environmental citizenship behavior of first degree part 1 with degree part 2 students, you are getting minus values. So minus value means, so your environmental citizenship behavior of degree part 1, here we are making the comparison. No? We compare with environmental citizenship behavior with degree part 2. Then you are getting the result of negative value. So negative value means this your second part is higher than first part. That's the reason, right? So that means the degree part 2, that means second year student environmental citizenship behavior is higher than degree part 1 students, right? That is why we get the negative value here. But if you are looking at the second one, that means degree part 1 to degree part 3, right? We are getting positive value. That indicate the degree part 1 student environmental citizenship behavior is higher than degree part 3 students. That's why we are getting positive value here, right? When the last one, that means part 1 to part 4, we are getting minus value. That means final year student, that means part 4 students, environmental citizenship behavior is higher than part 1 students. And remember, you have to check the significance. But these three things are not significant. Only significant values are here, right? Only significant values are here. Why? The 0.05, less than 0.05. So what you can see, the environmental citizenship behavior among degree part 2 students and degree part 3 students are statistically different. In other way around, degree part 2 students environmental citizenship behavior is higher than degree part 3 student, and it is statistically significant. When compared with the degree part, yes, the same result, right? Same result. And the second one, degree part 3 student and degree part 4 student environmental citizenship behavior is statistically different. How it is different? Compared to the degree part 3, degree part 4 students environmental citizenship behavior is higher than degree part 3 students, right? That's why we are getting minus value here, and only significant values we are concerning, right? Same value we can take in here, right? If you are concerning here, right? Then degree part 4 student environmental citizenship behavior is higher than degree part 3. So likewise, you can make the comparison of variable, right? If you have more than 2 categories in your factor, like new degree part, you can go with the one-way ANOVA test. Okay, right. Now assuming that I want to make sure whether gender, okay, whether gender, that means male and female, are going to be different, or whether female are highly concerned about environmental citizenship behavior, or male are highly concerned about environmental citizenship behavior, right? Then how we are going to check? Now we have only 2 categories, male and female. Then you can go with analyze, compare mean. We call independent sample t-test, right? Independent sample t-test, right? So then we select our target testing variable is environmental citizenship behavior. You can select whatever the variable you like, right? So, but my question is whether male are highly concerned about environmental citizenship behavior than female, right? Now my grouping variable is gender, and I'm taking this to here. Once you are selecting the grouping variable, you can see that the define groups command getting activate, right? If it is not there, it is inactivate, right? When you are selecting grouping variable, it activates. Then you click this define group box, right? So it asking how you define your groups. Right now I have two groups now. My first group is male, second group is female. Now, please remember, you have to put exact figures, exact value in here for the group 1 and 2. Right? Here I am using male for the group 1 and here female for the group 2. Right? Now, if you are using 1 and 2 for male and female, right, like we are coding it, like male like 1, female like 2. Here you have to put 1 instead of male and here you have to put 2 instead of female. Right? That's why I told you when you are entering data, the coding system is very important. Right? Now, this is a little bit uncomfortable. Right? If you have forget to see, type the right value, right? Like this, let me see. Right? See, you don't get the result. Look at this, right? If you have forget to see, if you are mistakenly type the incorrect one, you will end up with incorrect results, right? That's why I told you it's a very important when you are defining the groups, right? Here I'm making this correct. Continue. Now just click OK. Right? Now you get the result. Right? What you can see. Now this is the mean value of male environmental citizenship behavior. This is a female value, mean value of female environmental citizenship behavior. By looking at this, we cannot see significant difference, isn't it? But make sure that whether it has a significantly different or not. How we can check? Check the sig value. Right? Check the sig value. There are two things, but if you can look at the one, that is more than enough. Right? If it is less than 0.05, we can say there is a significant difference in environmental citizenship behavior with respect to male and female. But unfortunately, we get the value more than 0.05. Right? We get 0.591. It is greater than 0.05. So then we can say there is no statistically significant difference of environmental citizenship behavior between male and female. So then we cannot say male are highly concerned about the environmental citizenship behavior than female. So we cannot make that conclusion, right? So that's the way you can check the mean comparisons, right? You can check for whatever the things, right? Make sure that grouping is important when you are taking it, right? And your measurement item has to be in a item scale when you are taking the mean comparison. That means your testing variable has to be in a item scale. Okay, and if your testing variable is ordinal or nominal, you cannot run the independent or ANOVA test. Right? So this is the way you can check different things, right? And for your understanding purpose, if some of your dependent variable is going to be nominal scale, like yes, no question, right? You can ask the satisfaction whether you are satisfied or not. So your respondent say yes or no. You have only two, that is nominal variable. Or if you are taking ordinal scale, right? If you are taking ranking types in your dependent variable. So you cannot run the normal regression like what we did previous example, right? We can run multiple regression if your dependent variable is measured using item scale, like 1 to 5 scale. But if your measurement items are using ordinal or nominal scale, you cannot run that test, right? So you have to do the regression. You can see binary logistic. So binary logistic regression you can use for the, if your dependent variable is yes, no question, right? Yes, no question. Okay, then like here the dependent variable you can select your one, and independent variable it doesn't matter whether you ordinal, nominal, or scale type, you can take it as a covariate, right? And in here for the options you have to look at this correlation estimates, right? You have to take this correlation estimates, right? And Limoshow godness of fit, right? Let's take something. I'm not sure this one, right? Because I don't have a much proper detail to this. Let's see 1 or 2 in here, covariates, right? And options, I'm selecting hormone goodness test and correlation estimate. Okay, then check okay. Right, here you have to go with the enter remote. Like you can see the R square value, you can see, right? The homo and Lem's-Law test you can see. And then your, that's that coefficient table. Yes, the coefficient table is here. Variable in equation, you can see, right? Likewise, if value also there. So this is the artificial model, so I cannot say this is exact figures, right? But here again, R square value likewise is, if it is more than 0.3, it is better. In here, the Homer's and Lem's-Law test, this sig value has to be greater than 0.05. Not like multiple linear regression, this sig value has to be greater than 0.05. Then you can say the model is significant. Then likewise, the coefficient table, in here you have to check the variables in equation and its sig value. Okay, now this is the way you can run regression analysis if your dependent variable is nominal scale, right? And other way around, if your dependent variable is ordinal scale, like if you have order like 1, 2, 3, 4, like high income, low income, moderate income, or highly satisfied, moderately satisfied, highly dissatisfied, something like that, you have to go with the ordinal scale. Then select the ordinal one here, right? Like this, right? And then select your independent variable, so your factors, so select them as a covariates, right? And then you don't need to do anything in here. Goodness of it, everything is checking. Then scale, no need to do anything. Output, yes, here you have to check estimate response probabilities, right? Estimate response probabilities you have to check, right? And I think that's it. Okay, then click OK. It's also get the R square, values here. High square, you are getting high square value in there, right? So here significant value is okay, good. And this is your R square value, right? You have 3 R square value. You can select the first one, Cox and Snell, right? And this is your goodness of fitness of the measurement model. And these are your factors, right? So likewise, you can check those things with the significant if your dependent variable is ordinal scale. Okay, so that's the end of all the things we have to cover with main data analysis. So I will, I have already discussed with you how to do the factor analysis and how to check the validity, and then the reliability, then the regression with the multiple linear regression. And lastly, we discussed about ordinal regression as well as binary logistic. And I did some mean comparison tests for your convenience. So these are the things I want to discuss with you regarding data analysis. And I believe that I have covered most of the important part coming with your data analysis section. And if you need any assist or if you need further support, I'm really happy to help you. This is the way we can run the regression analysis, or we can run the data analysis using SPSS statistics. So I wish you all the best with your data analysis. And as I mentioned earlier, if you need any assist, please just let me know. I'm happy to help you all. So then good luck with all your studies, and wish you all the courage and all the strength for you to complete your master's degree. Good luck, all of you.